In this video, we are going to model a new post base for our shed structure. For this, we are going to have a look at new type of element that we haven't used or seen so far, such as steel shapes, connector axes, or bolts, nuts, screws, tight fit pins, etc. And we will achieve something like this. To design this, you will have all the information on this PDF, where we would have dimensions for the concrete base, cutting information for the post, and different information about the drillings and what type of element should be used as connector access. So here we'll just reopen the shed file we did in the last session, and we are going to add this connection on only one location, and then we will see how to easily copy that post base to all other posts. Let's start by cutting the post shorter and add this concrete base. In the first shop drawing, we see that the post should be shortened by 2 feet plus 9 inches. Let's just select that post with a left click using the bottom point as reference, because we are going to stretch it using 7. Do a lasso around the bottom extremity, and then when we see this arrow pointing downward, we will just set a negative value. So the negative value should be 2 feet and 9 inches. Oh, I forgot to enter the negative value, so let's just use tab to reverse. So here, if I measure the distance between my post vertically with Z to my concrete slab, I do have my 2 feet and 9 inches for the post base structure. So now we are going to add the concrete base. So to do so, and for it to be easier, we will enter a 2D plane aligned with Z, so Alt Z, and we will click here at the intersection of the grid intersection. And we are working at the intersection between 3 and A. This concrete base is square base, so it's 1 feet and 10 inches wide in the 2 direction and 2 feet high. So let's add a offset line. You can directly access this with the shortcut E, and then the value in both directions should be half the dimension. So here we can do 1 feet 10 and directly ask to divide this value by 2, so it will give us 11 inches, so 22 in total, and we just add the 4 sides using the grid. When this is done, we will need to add an auxiliary element to create the concrete base. Just note that here currently we are set to H. This means that the element that will be added inside the screen and not towards us. Since we are looking at the steel and the concrete base from the top, we need to change that for V, to element to the front, so towards us. And then go to add auxiliary element. We choose it to be concrete, so the same as the slab. We can call it slab, or let's just call it concrete, or just base actually. And the thickness, so that's the height of the block, and this is 2 feet. And just draw the outline with left click using auxiliary line intersections. Just to remind you that when you draw a surface or a contour in Cadwork 3D and 2D, you do not need to click again on the first point you have selected, because what you do is you select corners and you are not drawing lines. This means that here you have your 4 corners, so the obvious, like the logical step, is simply to connect these two, the first and the last point. So simply right click and Cadwork will automatically connect these two dots. When this is done, we'll simply right click to confirm. Here you can see that there is another concrete element at the top of our base, but this is exactly the width of that steel element. So we know its height, here we know its length, but we don't really have information about its width. It's because it needs to automatically adapt to the width of that element. So of course we do have the total width of this, but what we are going to do is we will first add that steel beam and then just add this concrete base based on the shape of that element. This will be easier like this. Okay, so now let's go back to 3D, and we are going to add onto that concrete base our steel shape. So here we are going to enter a plane at the top of that concrete base, so Alt Z, and I select with the left click one of the points of this concrete base. Okay, and I will just add some guideline like in the middle, so Y, M, and I will click here at the middle of the edge, and then X, M, and the same here, just so I have the center of my element. The steel shape that we need to add is 1 feet and 3 inches long. So again, E for auxiliary line with offset 1 feet 3 divided by 2, and click on the top and at the bottom. So here again we can make sure that this is correct by measuring. So we do have 1 feet and 3 inches. So that's perfect. And now we will still be adding the element towards us because we are looking at that plane from the top. But as you can see in the on the PDF, this element needs to be 1 inch higher than the concrete base. So let's see how we can do it directly in 2D without having to place it first, the element on the concrete, and then move it back in 3D. So this is something that we can do directly when we add an element. So this element is a new type of element. It's a steel shape. So you will find them in Add, Beam, always, and here at the bottom, Steel Shape. These elements are automatically generated. So this is the complete American library. And in our case, we need to find a HP 8 by 36. The HP 8 are wide flange bearing piles. So we will select here the first one, HP 8 by 36. Here again, when we add element from 2D, we need to set which face we are looking at. So here we are looking from the top view. We are going to name it rail and select the 2 extreme point. Now, during this stage, so as soon as you select the 2 points, the stage when you can move your element around the selected line, you have a shortcut called offset value with V. And this allows you to send or to move the elements in the perpendicular direction to the 2D plane. So in that case, we want to bring the element towards us. So it needs to be a positive value, and we need to move it 1 inch only. So 1 and OK. When this is done, you can just right click to confirm. And here we will add directly the second concrete base. It is 1 inch high and needs to go 1 inch around the base, since it has a 45 degrees chamfer. So E for offset line 1, enter, and here we'll simply use the outside of the steel shape as reference. And now we will simply go add auxiliary element concrete. We'll still name this one base. Thickness is 1 inches, 1 inch. We select the outline, and here we go. So now we can go back to the 3D. So here we have the first element. We are going directly to create the 45 degrees chamfer on both these element and this one. We cannot do them at the same time because they don't have the same depth. So first we are going to select this one. So cut, edge processes, chamfer 45 degrees. So here we need to select the edges that need to be chamfered. So we can either left click or select with a lasso and make sure to select only the top edges. So basically, as if we are using a lasso from left to right, we will select only the edges entirely within the lasso. So it's pretty safe to select the top ones directly. And now right click to confirm, and here this one should be 1.5 inches deep. Here we go. For this one, we are going to use exactly the same function, but not with this in the same fashion. So here I select the top face. I will go to cut, edge processes, chamfer 45 ways, and here you see that you can select facets directly. So F, and you select that face, and it will automatically select all the edges surrounding that face. Then right click to confirm, and then the depth. This one is 1 inch. Here we go. So now that we have this, as you can see on the PDF, there is 2 plates that needs to come next inside the HP8. It is centered, they are centered on the element and are cut right at the corners. Okay, so here we are going to add that plate in the middle of that beam, so we can select directly a point here to use when we will enter a plane aligned with Y. So Alt Y, and we just select that point with the left click. Since we want the plate to be in the middle of the element, we have to make sure that we will be adding the element on the axis. So set to A, and now we are going to add a panel, excuse me. So add panel. We'll use contour because we have all the 4 points available. Contour, and here always remember the element orientation when you add something in 2D. In that case, the thickness of the panel is perpendicular to the screen, so we see the width and length. So we will add it seeing the front. Steel element, call it plate. Thickness is 1/2 inch. And here we will simply select with the left click the corners or the inside of the steel shape. Right click to confirm. When we add something like this by contour, we always need to set the length axis because it could be in either direction. So here in that case I would simply select the left edge for my length axis to be vertical. Right click to confirm, and here we should have this cut by the steel shape, so we can select it and go cut, remove active equal soft. It means that it's the selected element that will be cut. And here I'm going simply to left click on the steel shape and right click to confirm. And here we are. We now have two identical plates on both sides of the steel shape. Since we are in that view, we can actually add directly the knife plate that should be added here at the top. So this element is 7 1/8 high, 10 inches long, and half an inch thick. So it means it's mostly the same as this one. So here to add this element, we already have the center line here with this steel shape axis. So Y and left click to add vertical line at the center of the post. Then we will add the height of the plate. So with E, so line width offset 7 1/8 right above. It is a half an inch thick, so half an inch divided by 2, so 1/4 on each side. Okay, add panel contour. We look at it from the cross section, so we see the thickness and width, steel plate. The length is 10 inches, and here we would simply draw the outline. Right click. Height axis, so the thickness is the horizontal of the plate. Here we are. So let's go back to 3D. So now we have all the important elements added. So we will need now to cut that post using the knife plate, and then we just need to add the connector axis. So for the knife plate, as you can see on the PDF, there is information about the cut tolerance. So the cut tolerance is something that can be assigned to an element to set an automatic cut when it's crossing elements. So we are going to select the knife plate and cut tolerance. So here we need to select the soft element, so the post, right click, and here we are. So I'm going to create a new cutting set called knife plate. When we create a cut tolerance, we always need to remember the element orientation or the element system axis orientation, because this is what is used to assign specific value in each direction. So here we have to the negative width, we have half an inch. We don't have anything on the positive. So here, since it's exactly at the end of the post, adding something or 0 won't change anything. Then along the thickness, we need to have 1/16 on each side. And along the length, we need to have as well half an inch. So on both sides. And apply. OK, and here we are. So here, if we want to check the cutting tolerance, we can measure from one corner of the plate to a corner of the cut, and we should find all the information we've set. So 1/16 along X, half an inch along Y, and half an inch along Z. So everything is correct. Now that we have all the elements and we no longer have any collision, we will be able to add connector axes, because connector axes cannot be added when crossed elements are colliding with each other. So here we want to add, we will add the tight fit pin through the knife plate. So we want to have the knife plate as reference, so we will need to select it. But here I will select the post first with that face, so I will be able to use that face to enter 2D plane, and then right click on the knife plate to select it. And to use the active face for your 3D plane, simply use dot and then right click to confirm. So here we are going to add the elements in the post, so we need to be set on H, so element to the back, and we will be adding some auxiliary lines to place the pin. So the pins are placed 1.5 inches from the top edge, then one is centered and the two others are also 1.5 inches from the edge. So here I will first add the middle line, so with Y, and then E, 1.5 inches, 1.5 on the 3 different edges. Here we go. So now we can actually add the connector axis, so add axis, and here when you add the connector axis, you see their section, or you see them from the side, so you are actually seeing the length. In our case here, it would be 1 point plus length. We'll choose like connector axis and name them pin. And so here we can directly select the intersection, and you will notice that the length that is set is automatically detected based on the element that was selected when we enter the 2D plane, and this means the actual thickness of the post. And now we are going to add some elements. So in the connector axis, it is a simple axe with 2 points, but to which you will be able to add actual elements. So here, if we select the 3 points, the 3 dots, we can choose among bolt, rods, lag bolts, screws, etc., etc. In our case, it will be tight fit pins, 3/4. By default, the pin is the same length as the post. As we can see on the shop drawings, it should be a 1 foot long pin, so you can unselect automatic, and here with the drop down list you will have all available length, and here you just select 12. You can choose the direction, so either it should be centered, placed at the start or the end. In our case, of course, it will be centered. Note that when you place an element, it can come automatically with a default drilling diameter. So in our case, it would be 3/4. And as you can see, there is plugs on each side to close the drilling on the post. On connector axis, you will be able to add elements to each interface. Interface are basically the line that separate each material crust. So you have air and the post, then you have an interface between the post and steel, and then again the post on the other end and air on the other side. So we are going to add actual plugs on each side. So just simply left click, and here you will be able to select among different elements, and we are going to add wooden plug. So here the plug we need to add is the 3/4 plug that you can simply double click. It will be added directly on top, or you can also simply take it and drag it, and in our case we are going to place it directly within the drilling. When this is set, you can simply use this arrow at the bottom to look through each interface, and we go all the way to the other side, and here we can add the same one, so that we can just drag inside. And you see this comes with also automatic drillings, but this is exactly the same as the main drilling. So for example, here if we change the diameter, you see that it creates another drilling on top. So here we keep the automatic one. When this is set, you can just press OK, apply, OK, and we are going to use this one to copy over. So simply click in the middle. Connector axis can only be selected by their main axis, so you won't be able to select any of the additional element added onto it. So 6 here, check connector axis configuration. So this is a question that will be asked when you copy connector axis. It's just that it asks you if you need to check the different elements that are crossed, because it could update the way the elements are added onto that axis, because the different element changes. But in this case, we have exactly the same configuration, but you can press yeah or no, it won't change anything. And again, at that location. Okay. So now if you go back to 3D, we have exactly what we needed. So if we look in rendering, you will see that it's an accurate representation of the drilling axis, the plugs, and the pin. Just note that the connector axes are different ways of being represented. So if you go to Vision, Materialize Axis, you can actually deactivate different elements from the connector axis. For example, you can hide the parts, so it's the bolt and all added element. Then you see that each time on the axis you see the different interface with the node on the line, and then this surface represents the different drillings that you have. So here if you uncheck drilling, you will just end up with an axe, and then if you uncheck connector axis, everything is invisible. Usually you use that, but you will check something else, for example here, to have a real representation of your connectors. In our case, I will always leave everything checked. Okay, and can display everything, so either with J or Shift A, and here we go. So now the next step is to add the anchors. So this is built with all thread, then with nuts and washers, and here we have the dimensions from the top of the plate. So let's enter a Z view using the top face of that element. So again, we select it, dot, and right click, so we know we are exactly in the plane we needed. We always add element to the back, and we will be adding some auxiliary lines. So with E, the first one is like 3 5/8 from each side, and 2.5 from the middle. So here I would just add a vertical line on is element axis and E 2.5 on each side. Now again, add auxiliary element, add axis, connector axis 1 point plus length. Connector axis, this one will be threaded rod, and left click at one intersection. Here we did not select the concrete base because the element don't go all the way to the bottom. So here in the first page of the PDF we have the total length of the axis, and that is 1 feet and 7 inches long. So 1 feet and 7 inches. Okay. And here the element that needs to be added is a threaded rod, a 3/4 threaded rod, 3/4. Its length, will leave it as automatic because you will see that for some element adapt to the other element that you add onto it. So in that case here we will be adding a washer and nut at the top interface. So just left click, washer. This has to be a 3/4 washer. You can just left click, it goes on top, it's exactly what we need. And then nut 3/4. Here simply double click on the nut to add it. Okay. And here you see the length of the element has automatically changed, just in order to be able to place the nut on top. And then here at the bottom we would just be adding 2 extra nut, so to be taken inside the concrete. And here the length is automatically updated and we have exactly what we are requesting from the shop drawing. Just note that if you need to have some spare length at the top, here you can add another length, for example 1/4, just for the element to stick a bit higher. But here we will use exactly as in the shop drawing, so let's say 0. When everything is done, just press OK. So now we can just select this one and copy it over. And right click to end. 3D, and here we are. So let's save. So now that the element is complete, we are going to see how to easily group that into what we call a container that will allow us to place that to all other posts.